The overall goal of this experimental characterization method is to predict a nanomaterial's particle emission behavior during its product life.
This method can help answer key questions in the nanosafety field, such as predicting a nanoproduct's safe lifetime. This aims to provide a use before date for nanomaterials.
The main advantage of this technique is that the experimental lifetime is accelerated. One doesn't have to wait decades.
Demonstrating the procedure will be Morgeneyer, a technician from our laboratory.
Assemble all the units and instruments shown in the experimental setup and make the necessary connections, as described in the text protocol. Switch on the circulation of the particle-free air inside the nanosecured workpost by pressing the Flux On button. Direct this particle-free air to pass through the emission test chamber by opening the chamber and keeping it open inside the nanosecured workpost. To set up the experiment, connect the particle counter directly to the emission test chamber to measure the instantaneous number concentration of the particles inside the chamber. Observe the concentration value directly on the display counter. While the particle-free air is passing through the chamber, continue to monitor this instantaneous number concentration value until it drops to 0, which ensures that the chamber is free of any background particles. In the meantime, chamfer the edges of the standard cylindrically shaped abradant by gently turning its one end in a to and fro motion inside the slot of a tool provided with the abrasion apparatus. Using a digital balance with a measurement precision.